Oh, man. That's my fault. Okay, let me turn these off a bit. Okay, I like it. All right, guys. So, if my data was 101, 114, 115, 117, 138, blah, blah, blah. Let's say it goes up to, blah, 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 up to 215, yes? Okay. When I go to make my histogram, how far does it have to go total? From what to what?
101.
From 101 to 215. So how much ground do I want it to cover? Total. How far is that? 114. You guys with me?
Yeah.
Alright, so far, the physical reality is, if I start at 101 and I want to go to 215, I've got to go 114. Meters, feet, whatever the shit is, yes? So I know I've got to cover 114 data points worth of stuff. If I know how many classes I want to use, if that's what you guys pick, how can I figure out how wide each class has to be so overall they go that far? So let's say I pick 6 classes, right? Say I pick 6 classes. And how far? You said I had to go minus low 114. And let's say I pick 6 classes. Doesn't it make physical sense that if I take the total distance I have to go, divided how many classes I'm going to use, it'll tell me how wide each class has to be. If I've got to go farther, they're all going to be a little bigger. Okay. If I use more classes, if I use 8, they're all going to be a little bit shorter, a little bit narrower, because you got more classes to cover the same distance now, yes? So if you chose 6 and somebody else chose 5, their class width is going to be bigger. Their classes have to be a little bigger because there's less of them. You guys with me? If I'm going to go from here to there using 5 steps, 1, 2, 3, 4, 5. I visually kind of estimated how big each step had to be. You guys kind of with me? If I want to go from here to there using 2 steps, I'm going to look goofy, right? 1, 2, yeah, okay. Look how freaking huge my steps had to be. That's a class. Yes? So, low, high minus low, how far I'm going to go, divided by how many steps I want to take, will tell me how big each step has to be. That's all that stupid thing is. That's all it is. There is a physical idea behind most of the equations we're going to do. You guys with me? Okay. This is one equation you have to just memorize because it's a little dinky little equation you guys can memorize.
So we're making the classes, so we're choosing.
You choose how many classes you want to use, which then informs how wide each class is. If I use less steps, less classes, each one has to be much bigger, yes? As I just demonstrated. I don't want to do it again because I feel lucky that I didn't pull anything.
Is there a rule of thumb on picking how your classes should be?
There is a formula for figuring out how many classes you should use that uses logarithms. If you want to, we can do that. Or, you can do like I said, most of our samples are going to be not that huge. We're going to use 5 or 6. Kind of makes sense. The smaller my sample is, the less classes I want to use. And the bigger my sample is, the broader my sample, the more data points I have, the more classes I want to use. It's going to get better.
100 or 200 data points, you would use 10, maybe 20.
Yes, exactly.
Okay.
Okay. Now, real quick, can somebody do 114 divided by 6? 52 divided by 3 is like 17.33.
19.
What is it?
19?
19? That was close. 19 point something? Or you got 18?
Just 19.
Huh?
Just 19.
Straight 19?
Yeah.
Dang, what did I do in my head? Oh, I did. Okay. I was so close. No. What if somebody had picked 5 classes? 22.8.
Yeah, 20.
Okay. Remember the shortcut, double it and then move the decimal. Do you see the difference there? And that's the choice you could make. They both are going to cover the same amount of data. One is going to take fewer steps. So of course each step is going to have to be bigger. Now here you would make this 23 because we're not gluttons for punishment. Stats is hard enough already, and let me not make my freaking class width insane. Yes? Okay. Is that okay? Okay. So I'll tell you this, when you're getting ready for a quiz, I'm the king of freaking handouts. So if you don't like handouts, you're gonna hate this semester. Use those damn handouts, yes, because they pretty much show you the kind of setup I'm used to and that I'm gonna give you. I'm not gonna drastically change the question I asked based on how I did a handout. But that said, I'm also not gonna make a problem exactly like the handouts, but still, if you understand the handouts, you'll be able to do the problems I asked. You guys with me? Yep. The book sort of has a slightly different approach to its problems. I understand that. But we went over a few examples of histograms, right? The main thing you have to do is calculate the class width and then set up the scale. Right? Everything after that is just, drawing the rectangle, which is nice. Okay. You guys semi with me? Okay. Any other questions on that? If I did this, where would my classes start? Well, where should I start my class, really? 101, right? You could start it at 100, but we're normally going to start at the first data point. How do I use this? What does it help me figure out? Here, specifically here. What's it help me figure out?
How far to go to the next number.
Good. So the next one down. Yes?
Yeah.
So this would be 120. So what would be here?
119.
119. Good. And then you just keep adding 19, blah, 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 until you make all your classes. In this case, I know I want 6 of them, yes?
Yep.
You guys with me? And then it's just counting, dividing, scale, box. Yes? Rectangle. Okay, maybe. Okay. Now again, please, dear God, if you didn't do so hot on the first quiz, and you feel like you probably didn't do so hot in this quiz, they're just quizzes. Quizzes are little checkpoints. They're telling you, hey, if you don't get this, you got time until the test hits. Because the test is going to be way more than the quizzes are worth. Each individual quiz cannot hurt you that much because they're each going to end up being worth about 3% of your grade, roughly, depending on how many quizzes. You guys with me?
Yep.
And you can make freaking corrections to them. Yes? And don't forget, and I do this if I have more than one quiz, I'll pick the one that is affected the most. But if you do better on the test and you made corrections to a quiz, it can go up again. Yes? If you got all the corrections right and you better, your quiz grade becomes your freaking test grade. So I've literally had people who got like a 30 something on their quiz because they had a bad day, they didn't do any homework, it sucked. Kicked ass on the test, got like an 89 or something, got all the corrections, so this quiz grade became a freaking 89. Do you understand what I'm saying? Do you understand? Okay. I'm just saying that because I have people at the end of the semester, they fail, and I'm like, if you would have just corrected a couple things, you could have maybe passed. And you would have done better in the final because you would have got more practice. Are you guys kind of with me? I'm sorry, I don't mean to be yelling. It just take advantage. Oh my God.
That sounds really heartbreaking.
Also, don't get used to it because not every teacher does that shit. Which I understand. They have a different, they make fun of my approach, and I'm like, yeah, it's fine. But I don't give a shit. My idea is your grade should be dynamic based on what you can show me, you understand. It shouldn't be as set in stone as it sometimes feels like. Okay. All right. Okay. So let go of that. Let it go. If you didn't do well and it's because you didn't really finish the homework, you can address that. If it's because you didn't get enough help, you can address that, right? So it's almost better if you didn't do as well as you wanted to and you can identify things you can start doing. What sucks is if you feel like you're doing everything right and you still get a bad grade, then you come talk to me. Or talk to me whenever, but especially then. You guys with me?
Yep.
That always sucks the most. And I've had that happen so many times. Your students are literally doing everything they can. They're still not quite getting there. We got to figure out what it is that's missing. Yes? Okay. I love you guys. Okay. So let me give you this before I forget. This is what's happening a week from today.
The test.
The test.
Yeah.
Yes. What the shit? Sorry. I like to echo what I think is going through your head. So I'll have this quiz back next time. What's going to happen in class on next Tuesday? I'm sorry, on this Thursday?
Quiz.
No,
Review.
review. Okay. So on this Thursday, I'm going to have the answer key to this practice test. Okay. By the way, I just said I'm going to give you the answer key to this, so do you think you should turn this in me?
Yes.
No, God, no.
No.
I'm going to give you the answer key. This is for you. Do you even have to do any of this?
Can you immediately make a paper airplane out of it and throw it somewhere else that's safe? Yes, you could. I don't care. This is just a study. Now, very quick. Yes. Sure, just a minute. I gotta get more back. Practice test, real quick. You don't have to do it at all if you don't want to. But at least you can see the kind of way I set my tests up. Because the very first time I taught, a student said, "What do your tests look like?" And I said, "I have no idea." So the first time I made a practice test, it was literally me practicing making a test. You understand? So I've done it ever since then. I'm going to give you the answer key on Thursday. Do as much or as little as you want to. The way I would normally do this, if I were you, is I would either try them, then check the answer key, and then go and focus on what you made mistakes on. Yes? Actually, that's the best way to do it. I love this. So please don't turn this into me. I got enough paper to carry around. Okay. All right, so before we jump in, oh, I'm sorry. I think a few more people. Is Damien here? Damien. I don't know when we're going to meet this guy. Mark is. Your last name is A, right? Yeah. Make sure I have you right here. Marcus, Marcos? Yes. Mary? Mary? Melissa? Alexia? No. Last name Tung. All right. Everybody got their quiz back, right? Okay, so go ahead and put your quiz away, put your practice test away. We're going to finish up chapter 2 right now. We're going to pick up right where we left off, if there's no other questions from homework or anything. Okay. Yes. Oh, wow. Yes. Yes. When are homework corrections due?
The day of the test.
The day of the final. When is everything else due? The day of the next test. So when are corrections to quizzes due? The day of the test, right? When is your original homework due? Day of the test, yes. When are homework corrections due?
Day of the final.
So I want you focusing on more recent stuff. Finals cumulative, so even if you make corrections to chapter 1 homework the day before the final, hey, you're practicing, you're getting ready, you know what I mean? That's why I do, okay. Say again? I never do, I hate that, sorry. Canvas makes mistakes in how it grades things. One time, a colleague of mine had to tell an entire class, "Oh, your grade is lower than it looks on Canvas. You thought you were passing, you weren't." So you know that. If my grade's gonna come out wrong, I want it to be because of me. Yes? So I do not post grades to Canvas. I will do this. Any damn time you want, you can come to my office, say, "How's my grade doing?" You can email me, "Hey, Professor Well, how's my grade doing?" You with me? Could you tell me what it would become if you made corrections on the quizzes? I will tell you. Isn't that silly? I will also give you a summary sheet of grades starting after the second test. I'll give out a summary, look at me giving it out. Summary sheet of grades, showing you what you've made so far, what you would have if you had all the homework turned in, none of the homework turned in, all that kind of stuff. You with me? Okay. You with me? I know it's weird that you had, communicate, find things out, but that's how, that's how life works. Canvas, I hate Canvas. I really hate Canvas. I just do. But I put shit in there, so yeah, okay. Sorry if you love Canvas. I don't mean anything bad by it. Okay. I guess this has to be a little higher if this is going to be here. So, anything else, guys? Sorry. All right, let's get back into it. I think the very last thing I put up here was this. What if we have 1, 3, 3, 3, 5 versus 1, 2, 3, 4, 5. You guys remember that? What was the average for both of these sets of data? I'll call this set A and this is set B. What's the average? Since I'm using that symbol, what am I saying that this is? Alright, let's try this different ways. What does this symbol mean? I just gave away the answer. The mean of what? Population, cool. So if I use this symbol, I'm telling you this is a population. Does a population have to be large? No, it can be any damn size. Population of 1, that's possible. You guys kind of with me?
Yes.
So what symbol would I use if I wanted it to mean a sample? X bar, kick ass. X with a bar on it. Very creative math people said, let's call it X bar. Okay, I love you guys. So the symbols, at least in the early going of statistics, will tell you if they have a sample or a population. Population, Greek letters, to make it all formal, Greek letters. Sample is just our letters that we stole from everybody else though. Okay. What is the difference then? And that's trying to be a 3 there in the middle, poor little guy. They're not the same set of data, are they? Anybody remember what we identified as the difference between them? Why are they different? What is the thing about them that's different?
I think we said B is deviated more and more.
Yeah. B, its data points get further away from its middle on average. Does that make sense? Do you all agree with me that B's data has more data points further away from its middle? They both have 1 and 5. But B has 2 and 4. They're different, aren't they? So A stays closer to home, closer to the mean on average than B does. So whatever this number is that we're about to create, it's supposed to tell me how spread out the data is. On average, how far away from the middle does it get? So what if my data was 33333? What should this number be that we're about to calculate if my data was 33333? A number that shows how spread out the data is, what should it be for that? 33333, is that spread out at all? No, so what should that number come out to be? It's 0, yes. You guys see? And when I get to 13335, it's going to be bigger than 0. Not crazy big, but bigger. It's got more spread than none. And then 1, 2, 3, 4, 5 should be a little bigger because it's got a little more spread. It gets away from its middle more. So for our quiz, on average, everybody's grade got 15.373 steps away from the average. You guys with me? So if I go 2 steps up, let me ask you real quick. Where would I go if I went 2 steps up? 2 steps. Every step is this big. 2 steps up would be where? How big is 2 steps? Roughly 30. So where would I end up if I went 2 steps up? 104. What if I went 2 steps down? 44. Yes? You guys with me? So that's how I can use the standard deviation to kind of move around my data. Okay. We're going to get there in a bit. All right. So let me do this. Did I already give that out? No. Should I? No. Let's just do that. Yeah. All right. So let me look at this one first. I can't remember how far I made it. I don't think I did this step yet. I want this calculation I'm doing. I wanted to measure the spread of the data. I wanted to measure this specifically, right? Do you guys notice how slow I'm talking? That is no time for damn sure. I want this to measure the average distance from the mean to every data point. So I'm gonna continuously come back to that as we develop the formula. It better be frickin' doing that or else we throw the shit out. So I wanted to calculate the average distance from the mean to all data points.
What is the first word?
Say again?
What is
spread is the average distance from the mean to all the data points. So that's what we're going to define spread to be. And I'm going to bring in the technical name for it here in a bit, but for right now I'm just going to reference it as spread. The average distance from the mean to all the data points. So let me ask you this. If I wanted to calculate the average left shoe size, I can remember if I did this with you guys already, in this room, what would I need a list of first? Left shoe sizes. If I want to calculate the average number of pets owned by people in this room, what do I need a list of?
Pets.
Number of pets each person owns, yes. If I want to calculate the average distance from the mean to every data point, what do I need first? A list of?
All data.
I want to calculate the average distance from the mean to all the data points. I need first a list of distances from the mean to the data points. So, what operation tells me how far apart two numbers are? Subtraction. Okay, beautiful. Okay. So if I take every data point minus the mean, it will give me an indication of how far away it is from the mean. Does that make sense? Because if I just ask you how far is 1 from the mean, you would tell me 2, yeah. Now the way we've chosen this mathematically, it will actually be -2, yes. Are you guys with me? 3 minus 3 is 0, so the middles don't get away from home at all. And then 5 minus 3 is 2. Okay. I really want this to make nothing but sense. Yes.
I'm sorry, the X with the bar.
Yes. Oh, I'm sorry. I always get ahead of myself. I'm saying right now, we're gonna come to samples. This is my mistake. This should be x minus mu up here, yes? We're gonna develop the formula for a population first, and then we're gonna show there's a little bit of an adjustment for a sample. Okay, thank you. The x bar would mean sample B. Yes?
Okay, so I think it's one number.
What's the mean? What's the mean for this data? 3. So what's the first data point minus the mean? 1 minus 3. What's 1 minus 3? What's 1 minus 3? -2, yes. Right? 5 minus 3. Okay, 3 minus 3. So I'm making a list of how far away each data point is. The same way you guys just told me, if I want to know the average, the average length of tails of dogs, what would I need a list of first? Length of tails of dogs. So if I want to find the average distance, I need a list of distances first, yes. And then again, add them up and divide by how many there are. What is wrong currently if I add them up and divide by how many there are? What happens? I get 0, of course. Any set of numbers that I do this for, that's going to add up to be 0. So then you go, thanks, Jeff, man, math boy. You led us to this horrible place. Everything's 0. Very nihilistic of you. So let me see. In algebra, in mathematics, what function actually talks about distance? What function always has a positive output? Absolute value, 11. We're not going to use them here for a couple reasons. So, do you guys remember that absolute value is always positive? You guys remember absolute value? Shit. Okay. So, it is going to come up later. So, the absolute value of -4 is 4. And the absolute value of 4 is 4. Because how far away from 0 is 4 and -4? They're both 4 away. You wouldn't say that either one is -4 away, that'd be weird. If you're -4 feet away from me, you're like, Quaid, in me, right? That's weird. That's weird. Can you stop for a minute? Yes? This is called absolute value. Yes?
So if it's negative, it's positive, and if it's positive, it's positive.
I love it. And why? Because it's distance. Would it matter right now how far away is he from me? About 3 feet, yeah? How far away? Well, 2 feet.
Oh,
2
you
feet,
wouldn't
2
say
feet.
like
I wouldn't say
-2
-2 feet. That wouldn't, again, -2 feet away means somehow he's inside. He's like, right? He's in.
Right.
Right? It's a little weird. Comes out. What happens?
So if you were to answer it and it was asking like how many whatever, right? would you do the little things and do like make
So-
it 4
so-
and keep it?
I want to bring up absolute value. You should all know what absolute value is, and it would make sense to use it here except for two things. One is, does anybody remember does anybody remember what an absolute value function looks like if you graph it?
Yeah.
It's like a V.
Yeah.
Now, I always use the same thing, but recently, there's been a lot of interesting troubles with planes, but just to bring up planes for a minute. If I was on a plane, I don't want to be on this plane. I don't want to be on this plane because this means we're dead, right there. That's infinite acceleration in that direction. Thank you for flying, but we're dead, okay? I'd much rather be in this plane, yes? Y'all agree? If we're gonna turn, this is the worst turn I want to experience in a plane. I don't want to experience BAM! Because we're all up against the side wall, smushed dead. Okay? You guys saw what'd you do in class today? We talked about dying in a plane. Well, that sounds great. What function is this in mathematics? Yeah, it's a parabola, it's squared. Yes, what else always has a positive output, or at least not negative? Squaring. So one reason we don't use absolute value is because it has this weird kink to it, this weird little sharp corner in the graph of it. More importantly, and something I'm not going to get into until later this semester, is if I took several samples and averaged their spreads, if I use absolute value, it's not the same as the whole population spread. There's a lot of shit in what I just said. Let me just say this about what I just said. Later we'll come back to that. But I want you to know there is at least 2 reasons as to why we don't use absolute value. So if I use an absolute value, it directly makes it positive, yes? Because absolute value is based on distance from 0. I just told you a couple reasons why we don't. So what's the next best thing we do? We square everything. If I square everything now, what am I going to want to do at the end? Square root. If this is the number of dogs somebody owns, and I square it, now I got little square dogs running around. Yes? Little Picasso dogs. That's maybe neat. I don't know if I want to come to your house or not. If you're like, I got a little square dog. I'm like, what happened? So, I really want you guys with me. Why did we make a list of these? Because I want an average distance, so I need a list of distances, yes? Why did we square the damn things? Because that's the preferable method for now to make the numbers not negative anymore. Why was it bad that I had some negative numbers? Because it would always add up to be 0. Okay. Hold on, so I'm gonna find the average squared distance, and then I'm gonna take a square root. Does that make sense? Why did it have to square? So the damn things aren't negative, so it doesn't add to be 0. Okay. I love you guys. I desperately want you to understand the ideas behind why we do things the way we do. Because we made this shit up. Statistics is the youngest class of mathematics, and in fact, if you go like just a few levels up, in fact, in this class, there's disagreement at the level of this class in terms of how to do certain things. And if you go even higher, it gets really murky. There's still people trying to figure out the best way to do things. This is the youngest branch of mathematics. 98% of what we do in here, though, is set. 2% of it, there's different ways to look at it. Can we stop for a minute? I love you guys. Kind of makes sense. The class all about probabilities and uncertainty is a little uncertain about itself. So what do I get when I square these numbers? 4, 0, 0, 0, 4. Now, real quick. Don't even write this, okay? Don't even write this. If I had a list of hours worked, and I wanted to find the average number of hours worked, don't even write this down. What would I do? Add them up, divided by, in this case, 5, the number of them, yes?
Yep.
Yes. If I can make a list of anything, if I want to find the average thing, I add up all the things divided by how many things, yes? So I've got a list of distances squared, so how do I find the average squared distance? Add them all up, divide by how many there are. I love it. If I add these up, I get
8.
holy shit. Now, what notation will I use? What would I put here that equals 8? What symbol did we just use? We added them up. What symbol is that? We haven't got the average or anything yet. We just added them up with symbol. I think somebody was signing it to me. Huh? Yeah, the E dude. The E thing. So again, right now I'm just talking about notation. Yes? Adding them up, that's easy. But I want to show you what it's going to look like in the formulas that you need to know how to use. So what we just did is we added up, what did we add up? All of these, yes? So I added up x minus mu squared, yes? So what was the sum of x minus mu? And what would it always be? What was the sum of x minus mu? 0, and that would always be true for any set of data. That's why we have the square, so we don't always get 0, because that wouldn't tell us shit. Now what's the next step in getting the average? We added them all up, so now we just have to divide by how many there are. I love it. So the official symbol for the population standard deviation.
Oh,
What?
I didn't realize it was standard.
Oh, yeah. Population standard deviation. The symbol is this. Let's all practice making that for a moment. So I start at the belly, go around to the hat. I start at the belly, go around to the hat. I start at the belly, go around to the hat. Yes? Start at the belly, go around to the hat. Yes?
Yep.
It's not a big deal, but it's not an R. You guys kind of with me? Depending on my mood, I can have very skinny ones, I can have very fat ones. It just depends on how I'm feeling. Okay. Fat and sassy, or skinny and weird. Okay. Now, real quick. If I do this, if I take these and I divide by how many there are, am I going to get the right number that I want? What did we say we have to do at the end to get the right number we want? I have to square root at the end, is what I do in the middle. Squared everything. So I made little square puppies running around. I don't know. Little Minecraft stuff going on. So I haven't square rooted yet, so it kind of makes sense that I want the symbol for what we've done so far, I want it to be this. This, sigma squared, by the way, that's lowercase sigma. This is called the variance. So what is the variance for this problem? It's 8, right? And this is another thing you guys are not used to. This whole thing is 8, yes? I don't plug stuff into x. I don't plug stuff into mu. That is the sum of business, and I got to put the number that I get when I add them all up, yes? This is very different from algebra. I don't put a number here. This whole damn thing is a number. It's 8. We added them up and we got 8. Divided by what? 5. I love it. So what is that?
1.6.
1.6 kick-ass. So, that is not the population standard deviation yet. What's the last thing I have to do? Square root. Be very careful. Don't assume you know what that is. It's not 0.4. So in your cockle letter, what do you get for square root of 1.6? So 4 over 9, 4 over 3 is like 1.33. So I'd say like 1 okay, around there. Go more for me.
2649.
All right, so always round your standard deviation to at least 3 decimal places. Always round your standard deviations to at least 3 decimal places. Dear God, don't give me 11 decimal places, but at least 3. Yes?
Okay. So, population standard deviation is the answer that we just got right now. That's the answer.
Yes.
The little belly thing that you did.
Yeah.
What is that again?
So, real quick, the symbol is a Greek letter. It stands for population standard deviation, but the name of it is sigma. It's lowercase sigma. Like the E dude is uppercase sigma. The fat R dude is lowercase sigma. That's the name of the Greek letter. What does it stand for in statistics? Population standard deviation.
So doing that squared is the variance, and that was
Yes.
what was the 8, which is how you get.
Well,
in
sigma squared is
zero.
1.6,
Yeah,
right?
yeah.
Then we square rooted that and we got the population standard deviation. So before you square root it, we call it the variance. It has meaning that we're gonna talk about later this semester, but right now it just means we're not done yet.
Got it. Okay, cool.
I like it. So that's how Excel calculated this almost. Notice this has a letter S, yes? What do you think that means? Mu is population mean, X bar is sample mean. Sigma is population standard deviation, S is probably sample standard deviation. I love it. Okay. Stop for a minute. The basic idea of what we just did a lot, is we got the average distance from the mean to every data point. That inherently makes sense as a way to measure spread. Were there other ways we could have measured spread? Yes. Were they better in any way? No. That's why we chose this. Let me guess. So you guys look like you remember me. I'll be all right. Now, okay. So if I did, yes?
So for the decimal, the 1.265,
Yes.
we wanted to have it 3?
At least 3. So you can go 4, 5, 6, but at least 3 places. Don't round it to 2 places, 1 place, round it to at least 3 places. Because later we're gonna use that in formulas, and the more you round, the more off your result's gonna be. So if you got at least 3 places, you should be on target. I could talk about significant figures. Have you guys ever done those before? Where's my chemistry peoples at? I'm not going to. So I'm really, if you wanted me to, I'm sorry, I'm not. Just round to at least 3 places, and we should be golden in most situations, okay? All right. Now, let's do this one more time, and then I'll let you guys do it on your own. Let's do it for 1, 2, 3, 4, 5. Somebody, can you predict what we should get? We got this for 13335. Can anyone tell me what should be true about what we get for this set of data? Anything, tell me something. We got 1.265 here.
It'll be more spread out.
So the number we get should be higher. We know it should be. If it isn't, the whole thing doesn't make any sense. We'll throw it out, we'll go home, and everybody gets an A. And now you're like, make a mistake, math boy, come on. All right. Now I feel, oh shit. All right, let's do this one together. All the same steps. So I'm gonna do X minus the mean. And again, what's the mean here? Can you guys see, since it's nice and symmetric, the mean is 3, is that cool? Or you can add them all up divided by 5, yes?
Never mind, you're saying it.
You don't have to see on site what it is. You can still add them all up and divide by 5, yeah. So what do I put here?
2.
Yeah, -2.
0.
Okay. And just to check, I could add these up, you don't have to, and it should come out to be 0. If I round my mean at all, what might happen there? If I round my mean, what might happen here? I won't get exactly 0 because I've rounded my middle. It's not in the right place anymore, yes? If you don't round your mean, that should always be 0. Because the mean is in the middle of the data according to the values of the data. So of course I'm going to have equal amounts negative and positive on either side. Yes?
If you do get a decimal, how far should you round?
Not very far. If you get 0.5 or negative 0.5, that's a little far. But it depends on how much you round it. Yeah. What do I do next? Because of the silly 0, the negatives.
Square.
Square. So just square everything. Now what do I do?
So you have 10, right?
Add them up. Okay, why am I adding them up? Because at the end I want to get an average, so of course I got to add the damn things up.
Right.
Because that's how you get an average. Add them all up and then, yeah. So what's the, you said the sum of this
10.
is 10. See how nice I'm being to myself? 10 is this. So anywhere I see this, what am I going to put there? Freaking 10. And what's the formula for population standard deviation? It's this crazy business, yes?
So the N is the
Number of data points. Thank God, N always means the same thing. Number of data points I'm looking at. I love it. So what goes on the top there?
10.
Freaking 10. So again, I can't stress this enough. You don't put shit there. What could you put there? What does that represent? That letter right there, what does it represent? It represents all these numbers at once. So you can't put anything there, yeah? This whole thing is 10. And of course, what's in? 5 data points. You guys are getting ahead of me. So this, what is this again? Variance is 2. So how do we get the standard deviation? Square root. Did it do what we knew it should? We didn't know exactly what the number would be, but what did we predict? It should be bigger than this one was because it's more spread out, and it is. Just a little bit, which makes sense because it's just a little more spread out, yes? I love you guys. Okay. This is your first real formula. So just to remind you guys, for the test, part of what we're going to do on Thursday is the very first thing we're going to do is I'm going to make a formula sheet with you. It's going to be very small at the moment. There's only like one more formula we're going to talk about, sort of 2. But that's our main one, well, sort of 3. So, all right. Remind me, what was this for? What kind of group did we just calculate this for? Population, kick-ass. Now, let me see. I'm going to try to explain. There's one thing that happens that is actually different. For example, if I'm working with a sample, what should go here? X bar. So that's not the kind of change I'm talking about. That who cares about? That's aesthetic. There's an actual change that's going to happen to the formula, and I'm going to try to explain why right now. There's one little thing that changes in the formula. Oh, okay. Do you all agree with me there's currently an average age? I'm going to leave me out. Average age of everybody sitting down in this room? Yes. Every one of you is a certain distance away from the average age. Do you agree? Yeah. Just so you can imagine making this table for everybody. You with me? Okay. So we really, okay. That's not that big of an idea. What if I just talk about these people and their average age? I really want this to make sense. Would each of the people in this sample, would they be closer to their average or further away from their average than the average of everybody?
Closer.
Doesn't it make sense that since I calculated the average from them, they each would be closer to the average, wouldn't they? If I just happen to randomly pick a bunch of younger people, their average age is going to be smaller, they're going to be closer to it, aren't they? You guys see what I'm saying? So more than likely, any sample I take will be smaller than the actual population would have been, this population standard deviation. I really want this to make sense. They will be closer to their own average than to the population average. Yes?
Just because there's less points, right?
No. Because whatever the average is, it came from their data points. So real quick, looking at this, 1, 2, 3, 4, 5, right? This is not very big, but that's okay. What if I chose, so this has a certain standard deviation, yes? What if I just chose 1 and 5? Let me do this. What if I chose 4 and 5? Are they closer to the population mean? Or are they closer to the sample mean? Do y'all agree this is a group that I chose from the population, yes? Is that group, is their data points closer to the population mean? Or are their data points closer to their sample mean? Yeah, 4 and 5 are closer to 4.5, yes? Do you see how that would work for almost any sample you could take? Because the average comes from those numbers, of course those numbers will be closer to it. It'll be more in the center of those numbers. Are you guys kind of with me? Yes?
Back to the other notes,
Square root of 2.
Square root.
Yeah, how do I kill the square? I take the square root. Yeah. And I'm a math geek, so I have square root of 2 memorized. All right. Yes.
Okay, so your sample you're just taking from the population.
Yes.
Okay.
I love it. In fact, what is the definition of a sample?
A number describing. the
No.
population.
What is this definition of a
Subset
sample?
of the population.
Subset of the population. So subgroup, subset of the population. Yeah. Okay. So, what I'm trying to say is, if I have a sample and I use the same formula as if it was a population, I know my answer is going to be smaller than it's supposed to be, because they're all going to be closer to their own average than they would be if it was a population. Does that make sense based on what we just talked about?
Yes.
The adjustment we're about to make, I'm going to explain it in a different way in a minute, should make the answer a little bigger for a sample because of the fact that I don't have the real population. So if I force it to always be a little bigger, I should get closer to the real answer. So here's the idea. Here is the formula for a population standard deviation. Or variance, right? You make it like this, maybe just make it really gross. I don't know if you guys can even see theirs. See how I square rooted it, so it's a standard deviation, yes? For a sample, the first change is this will be an S, and this will be an X bar, because I'm talking about a sample now, right? I want to use R letters for samples.
So X bar means sample,
X bar means sample.
deviation,
What does mu mean?
mean,
Yeah, population mean.
population,
What does X bar mean?
population.
Sample mean. Greek letter, population. Our letter, sample.
Okay, so sample mean.
Good. Sample standard deviation. Sample mean.
Got it.
Greek. Population standard deviation. Greek. Population mean.
Is that an S?
That's a poor little S, dude. Yes.
Sorry.
He's having a rough time. It's even worse. Oh,
It stays square.
the stay square. Yeah. Sorry, I was halfway through doing this.
No, you're good.
Now here's the trick. Let me ask you guys. What do we? Again, there's two levels to this. Either you can just not even listen to me la when I try to explain something and just throw shit to formulas. But it's a little better if you understand why you use certain formulas when. Did you all agree with me that if I use the exact same formula for a sample, it's gonna be smaller than it should be? Because they're gonna be closer to their own average than if I compared it to the whole population. You guys good?
Yeah.
So on one level, this makes sense. It doesn't make sense about exactly why we do this yet, but let me ask you, how do I make the output of a division problem bigger? I make the bottom smaller. If I divide by less, the answer I get is bigger, yes? So instead of divided by n, we're going to divide by n minus 1. So on one level, that makes sense. The idea that the bottom is bigger, so the whole thing, bottom is smaller, so the whole thing is bigger, to account for the fact that by the sample, they're going to be closer to their own average than the whole population. Okay, let me stop for a minute. Now, a very desperate attempt to explain why it's freaking n minus 1 and not n minus 2 or whatever. Yes. So let's say I have a population and I choose 3 numbers from it. And I know the population mean is 10, yes? Do I know anything about any data points in the population? No, I just know that they have to average to be 10, correct? How many, let me see, I'm doing it 2 different ways at once. Let me just say it this way. How many numbers could you just completely make up before you have to get serious to make the average 10? I sort of talked about this earlier this semester. See if this makes sense. Could the first number be 3? And the average eventually still be 10? You guys with me? Could the first number be 18 billion?
No.
Of course it could, because the next number could be negative 18 billion. Do you guys see what I mean?
Less than 10.
So do you see how the first number could be any damn thing I want it to be? So my question right now is, I really want this to make sense. If you're just gonna make 4 numbers that average to be 10, Do any of the numbers have to be anything specific?
Just
No, just one of them needs to be based on what you pick for the other three. So I know what you're thinking, but I could make any numbers for all four as long as the last one makes it come out to be an average of 10. Exactly. So could the first one be 3? Sure. Could the next one be 3? Could the next one be negative a billion? So how many of these can I just totally make up for after? So help me out, just 3. Somebody give me the first number that comes to mind.
55.
Say again.
55.
55? Cool. Somebody else give me just whatever the hell. Whoa! I don't know how to, what number is whoa?
7.
7! Okay. Now I have to get serious, don't I? Can I salvage this thing? If I want the average to still be 10, can I salvage this?
Yes.
Of course I can.
You have to add them.
If I have 4 numbers that average to be 10, they have to add to be, if I have 4 numbers that average to be 10, they have to add to be 40. Because what do I divide by 40? 10. 40. So I don't know what any individual numbers have to be, but they have to add to be 40. Can you salvage this? Understanding that I can have negative friggin' numbers, yes?
Yeah.
So right now, what am I adding up to be?
65.
So what's the last number have to be? Negative 25. Kick ass. So real quick, before you write that down, what if that was the sample I picked? I got 3, 55, and 7. Yes?
Yeah.
Is the average of the sample the same as the average of the population? Obviously not. You guys with me? In fact, what is the average? It would be 65 divided by 3 is something. I think somebody's agreeing. Yes, it is something. It's 20.667.
Yeah.
Roughly.
21.
Yes.
Damn it. You guys, I really want you guys with me. If I have a whole population and the average of the population is 10, couldn't those 3 numbers be 3 that I pick from the population at random?
Sure.
Isn't there always one number that exists that would make that the same as the average of the population? You just told me what it was for this one. What would it be?
Negative 24.
Negative 25.
Or 25.
Negative 25. Because right now it adds up to be 65. Negative 25 makes it add to 40. Just to make sure you guys are really. If I make this negative 25, this all adds up to be 40, yes?
Right.
Divided by 4 is 10. Check. So for any sample I pick, isn't there one other number that we don't know that would make the average of it the same as the population average? That we just proved that.
Yeah.
Any sample we pick, isn't there one other number we could have picked that would make it the same average? Just that idea. No specific numbers. Any sample we pick, isn't there one more number that would make the average of the sample the same as the average of the population? Yes. We just proved that. We didn't really prove it, but previously.
Where'd you get 40 from?
If I have 4 numbers that average to be 10,
Oh, so the average is 10 plus 4.
well, 10 times 4. I need them to add to be 40, so when I divide by 4, I get 10. So real quick. Every time I take a sample, I assume I have n minus 1 of the data points, because that nth data point is the one I don't know. Which is why in the formula I divide by n minus 1, because I'm going, if I just had that last data point, the mean could be the same. I want to give you some idea of why the damn formula has an n minus 1. And n minus 1 is going to come up again later this semester. That's why I'm okay with calling it right now. So let me ask you this. How many data points did I end up with in that list?
This one?
Yes, 4. How many of them did we have complete freedom to just make up? 3.
Oh, 3.
Right? When did we have to get serious? At the 4th one, yes? So for any set of data, I can make up one less. If I have 28 data points, how many can I just make up?
27.
27. So if I have n data points, how much freedom do I have to just pick whatever I want? N minus 1. So it's called, this n minus 1 idea is called the degrees of freedom.
So
Degrees of
creative.
freedom.
So creative.
Take away my statistics, but you can't take away my degrees of freedom. Sorry. If you've never seen Braveheart, then you still haven't seen it. Yes.
What's that? When you put equal, what's that? Is that 10 squared?
What is it, sorry?
Is that 10
Down at the
squared?
bottom, it says 40 divided by 4 is 10. Yeah.
That's 10 squared?
No, it's a check mark.
Oh, check.
Yeah, meaning now it's the same average. Okay. So, where did I put it? Oh, that's why the formula is the way it is. So let me give you this. I think I got just enough time. So, on one side of this paper, I have a completely worked out problem. Just focus on 1A and B for the moment. There's the little formula we just created. So that's one of the formulas that could be on our formula sheet, yes? So this is a completely worked out problem. I'm even gonna show you in a minute how to put all this in the calculator so you can have it do all this stuff for us, yes? Because we're not here to be tested on how can you subtract and how can you square. We can make this stupid little expensive ass calculator do that for us, yes? Okay, so to explain the rest of this, which I never remember to talk about before I get this out. For that data we just had, what was the standard deviation again? Was it 1441? Is that the one? 1414, yes? Okay. Because it was square root of 2, yeah. How many, so I am very often going to refer to this as a step. This is how I step around the data. For example, I said this the last time I think. If I wanted to measure how far apart two people in this room are, I would not use miles, correct? Because on average, we're not miles apart. If I want to talk about how far apart two towns are, miles. If I want to talk about how far apart two stars are, I can talk about astronomical units and all this kind of business, yes? There's not even stars, planets. With stars, I could use light years, yes? Okay, let me stop for a minute. So even in the natural, normal world that you experience all the damn time, you pick the unit of measurement based on the average kind of distance, yes? Isn't the standard deviation the average distance from the mean to the data points? Isn't it a natural, although less natural than us because it's just numbers, but it's a natural thing to use to designate how far apart things are, yes? So I can talk about very often, as I talk to you informally in the classroom, I'm going to call a standard deviation a step. In fact, I think I've already done it several times. It's how I step around the data. Yes? So, has anyone ever been to Denver?
Yeah.
Would you agree with me that that city is like spread the shit out?
I was in the airport.
Oh, well, shit. No. I'm in a lot of airports, I wouldn't count it, you know what I mean? But Denver's like spread out like crazy, yes? And has anybody ever gone on a road trip? Have you guys ever seen where the speed limit slows down and speed back because you're going through a little town? If you blink, you'll miss some towns? Yes? So if I wanted to get around town, in the little town, if I make my step size too big, I'm gonna skip the whole town. In the big ass town, my step size can be big and I can get around the freaking town. So if I have set of data and I want to get around the data, the standard deviation gives me a unit of measurement to get around. Like picking miles versus inches, depending on how spread apart things are naturally. So the standard deviation is how spread apart my data points are. So I can use it as a way to get around. Now, in the real world, once we figure out how to measure, I can use inches versus feet. How do I actually measure how far apart two people are? Well, I put a freaking ruler or a yardstick or something down, yes? Especially if we're in America. Everywhere else on the face of the earth, they're not gonna use a yardstick. Okay. You guys kinda with me? So I can use a yardstick and I can put it down. So, let me ask you this. If every step is this big, how many steps? Let me do this more officially. How many standard deviations away from the mean is the data point 4? Is it a full step away? What's a full step away from 3? What's a full step above 3? Yeah, 4.414, you with me? So is 4 a full step above? No. How would you figure out exactly? Divide what?
The data point by the standard deviation.
No.
Average standard.
What am I trying to measure? The distance, correct? This is going to be a lot like class width. How far do I have to go divided by how big each step is?
Okay, wait. Where did we get the 4 minus 3?
How far do I have to go? If I'm talking about the distance from the mean to 4, how far do I have to go? 1, don't I? So, I'm talking about the distance from where I am now to the end of the desk. Couldn't I tell you how big in feet it is?
Yeah.
If I subtract how far that is away from where I am?
Yeah.
I can see how far it is, yes? So, if I want to get from 3 to 4, how far do I have to go? 4 minus 3, I have to go 1 data point, data length, yes? But how big is every step I take? 1.414. So when I divide those two, I'm going to get something less than 1, which we knew it wasn't a full step away. So the little z dude I wrote down there, without even thinking about it, is called a z-score. Standard deviation is choosing whether to use inches or feet or miles. Z-score is actually laying the freaking ruler down and seeing how many of those something is away. So how many steps, how many standard deviations from the mean to 4 that's roughly 0.7. What is it?
0.707.
707. I like it. So if you got a grade that, a test that, and your z-score was 2, what does that mean?
That's your overall score.
No, your z-score is 2.
That's,
Your 2 standard deviations above the mean, away from the mean, yes? Because you're positive. You're 2 steps above the mean. That's good. That's relatively good. You could have still gotten like a 40 like I did on the first graduate test. But relative to everybody else, that was really good. Yes? What if I got a z-score of 0? What would a z-score of 0 mean?
You're 0 steps away from it.
So what was my grade then? It equaled, in this case, what would my grade have been? About a 74, yeah?
So 7.
If my z-score is 0, that means I scored exactly the average.
Okay.
What if I got a z-score of negative? I got below average. So z-scores can be negative, that just means you're below average. Yes? Because what's a z-score of the data point 2? It would be data point minus the mean divided by the spread, so I'll get negative 0.707. The negative means I'm below, and I can tell I'm not quite a full step down. This is how we measure how different things are relative to the whole data set. Yes?
I think I'm still confused on the top. Like, I get what you're doing, but the top, I don't know why it's confusing.
So
2 minus 3.
that's how far away the data point is just in absolute terms. It's 1 below the mean, yes? If I said where's 2 related to 3, you'd say it's 1 below.
So you're trying, like, what are you trying to, I don't know how
So
to.
let me say this. What if I had, let me give a different example with nice numbers. What if I had a bunch of data where the mean was 10 and the standard deviation is 2, yes?
Okay.
Let me say it like this. The mean is 10 and the standard deviation is 2. Where do I end up if I take 2 steps?
12,
2 steps.
10, 11, 12.
How big is each step? What did I say?
2.
Yeah, so if I take 2 steps, where do I end up?
14.
14. Yes? How big is each step? 2.
Also, you're going by 2? When you move.
Because that's what standard deviation means. It means how big of a step is a single
And
step.
then you're taking 2 steps, so 2,
Yeah.
4.
So if I want to do that backwards, so this, what I just did was, I did the mean plus 2 steps, yes?
Got it.
If I didn't know this, if I'm like, how far away is 14 from what's the z-score for 14? How many standard deviations away is it? I would say, well, how far away is it divided by how big each step is? So again, if I wanted to go to -7, yeah, not -7, sorry, 7. I'm thinking it's below me. Can you tell me, it's not going to be 2 steps, is it, down? Right? It's not 2 steps down, is it? And it's not 1 step down, it's somewhere in the middle. You agree? 1 step down would be 8. Is that cool? Every step is 2. If I go 1 step down from 10, I'm at 8.
Yeah.
2 steps down would be 6.
Okay. Yeah.
So that's exactly in the middle of those, yes? So you already know the answer should be, what's in the middle of 1 and 2?
1, 2, 5.
1.5, yes.
Yeah.
So let's see. If I do the z-score, it'll be the data point I'm curious about minus the mean, just to see how far I've got to go, divided by how big each step is. So the formula is data point minus mean divided by the standard deviation.
So the one you're curious about minus the mean.
Divided by the standard deviation. So standard deviation is how big each step is. X minus the mean tells me how far I've got to go. So it makes, if I know, if this is the mean, I'm at the mean, correct? Right here's the mean. And this is the data point, yes?
Right.
You with me? This is the data point. And I'm like, every step I take is this. So I'd say, how many steps does it take to get over there? How far do I have to go? Divided by how big each step is. That's how many steps it's going to take.
So if you were like curious about like 12, right? That's 12 data points. So you can do 12 minus 10 because 10 is the mean divided by the steps.
Which is
That's
2.
2 steps.
So that's 1 step like we knew.
Yeah.
12 is 1 step above 10 because every step is 2. So let me ask you this. Would you say that 12 is close to 10?
Yeah.
It's only 1 step up, correct? What if I have a different situation? I'm telling you it's a different sample, it's a different population, and I just say, is 12 close to 10? Why can you not tell me? You don't have a clue how close those are.
Don't know.
Because you don't know what's in
Don't know how big each step is. What if every step is 0.1 big? You with me? What if every step I take is 0.1? Can anyone figure out what the z-score would be in that case? Just to remind you guys, this is mean here, still 10. 12 minus 10 divided by 0.1. 2 divided by 0.1, 2 divided by 1/10 is 20. It's 20 freaking steps, yes? So it is relatively very far away. So if I just ask you, is 3 really far from 4 statistically? Your answer should be, I don't have a freaking clue, man. What's my standard deviation? If my standard deviation is 10, 3 and 4 are really close. They're not nowhere near a full step away. If my standard deviation is 0.000, they are light years apart. They're crazy far apart. You guys follow? So when I find a statistically significant outcome, that means the z-score is big. It's far away from what I expected to happen. Yes? So if I have an expectation of an outcome of a disease, and I'm testing a new drug, and my results are very far away from what I expected, that's a statistically significant outcome. So that's what z-score measures. How different is it from what I would expect? Maybe. Now it's going a little further, but I wanted to get there. So let me do this. Let me do 2 things. This is obviously if I have what kind of data, population or sample.
Sample?
Why is it a population?
Oh, because of the.
It's all Greek, yes? This, thankfully, the formula doesn't really change, just the symbols change. You guys see how the formulas here are the same? Data point minus middle divided by spread. They both say the exact same thing, just one's for a population, one's for a sample. They're both basically the same formula. Do you guys see that? Okay. All right. So, all right. Let me do this with you guys. Has everybody got a calculator? You should still have the calculators you borrowed, if you borrowed some earlier. If you didn't borrow one, come up and borrow one real quick. Did I leave mine home? Yes. Oh. No. Sure. It's kind of gross. Do I have a normal one? No. Yes, I do. So everybody, take a moment. Let's see, I'm gonna go into my list real quick, and I'm gonna clear the data that's there. Just go up to the list and hit clear. Now let's put the data in. Jeff, you can do it, buddy. Damn it. Can you? There you go. So one really nice thing to notice when you put stuff in, what spot should I end up in? How many grades were there? 12. Thank God I ended up in the 12th spot, right? And then you just double check. Okay, that's good. Yay! You don't have to, but let's go ahead and sort this. Just kind of makes it easier to do the table. Remind me how to sort this thing? Stat? Sort, that's crazy. And then I have to tell it list one. Very anticlimactic. Done. There we go. Now, let's see. What do these represent? Everything in L1 represents what? What variable do we use? What letter do we use?
X.
X. So my X's are in list one. And do you notice how I've got that here? You can put this down here if you want to. Don't I want this to be X minus X bar? And where'd you just tell me my X's are? Where'd you just tell me my X's are? In list one. So don't I want list two to be list one minus the mean?
Yeah.
Okay, so real quick. Can somebody add those up for me?
They're 78.
Good. And if I divide that by 12,
6.5.
6.5. Why should I not round to 7? Why would that throw things so off? What's the whole idea of standard deviation? How far on average we get away from the mean? If I move the mean, doesn't that change everything?
Yes.
My standard deviation is going to be way bigger than it's supposed to be. So try to never ever round the mean. So I could do every row. You never have to do what I'm about to show you. You can do every row just one at a time, or you can make the damn calculator do some work. So what I'm going to do is, don't I want list 2 to be something? So go up to list 2. Do you see how the bottom now says list 2 equals? It's just sitting there waiting for me. What do I want list 2 to be? I want list 2 to be everything in list 1 minus 6.5, minus the mean. So if you've ever used Excel, this should be a little familiar. If you've never used Excel, it doesn't matter. It's pretty straightforward. Huh? Oh, it's above 1, so you do second 1. See how it's above 1? Yeah. Let me know if you have any issues. Make sure you have the list 2 highlighted. So I'm gonna make a mistake right now. I'm gonna do it right here. See that where I'm in the wrong place? If I do list 1 minus 6.5, it's gonna give me an error. It's gonna say data type. I'm trying to put an entire list into one spot. Calculator's freaking out. I'm like, I'm sorry, calculator. List 1 minus 6.5. Bam. You guys with me? That's nice. That's nice.
Yeah.
Yes? And then what do I want this one to be? What do I want to do with those numbers immediately? Square them. Go over to list 3. I want it to be every number in list 2 squared. Every number in list 2 squared. Bam. Now, I will point out one thing that sucks. In Excel, if I go back and change this changes automatically. Not true here. If you change something here, this does not change. Yeah.
Oh, can you show the square?
Yeah.
Just for list 3.
So I want list 3 to be this, everything in list 2 squared. It's exactly the same work we did before, correct? So I'm going to go up to list 3. Make sure you have list 3 highlighted, so it's down here saying, what do you want L3 to be? And I'm going to tell it, I want L3 to be L1, second 1, sorry, L2. L2, second 2, L2, squared, which is right here. L2 squared, bam.
How did you get the data that you got in L2?
Okay, L2 was L1, right? All my x's are in L1, so I want L2 to be everything in L1 minus the mean, which was 6.5. So again, if you go up to L2, I want it to be L1 minus the mean, which was 6.5. Now, what are you hoping this calculator can do? What do we want to do with all the stuff in L3 now? What do we want to do with all the squared distances? What do we want to do with them? Add them, because we're trying to find an average. Of course I want to add them. Right? And thank God this calculator can do that. So here's what you got to do. Get out of the list. Hit second mode to quit. What did we just say? I wanted to sum up a list, correct? So if you go to if you go to second stat to list, yes? See above stat where it says list? I can do shit to lists. I can do math to lists. I can sum up a list. I can sum up list 3. Bam. So that is what goes up top here. And then you keep going like we did earlier to finish it out. So I'll tell you this. Next time, first thing, we'll make a formula sheet. I'll have the answer key with me next time. I'll have the quizzes graded. We'll finish up this sheet first thing. Yes? If you want to finish it yourself, fantastic. Little tears coming out. We'll do a couple more examples with the z-score. I'll talk about what the hell's up with this problem. Okay. Everybody got a practice test, right? Okay. Everybody got the quiz back from last time? Okay. All right, guys, so Thursday I'll have this new quiz graded. Let me know if you have any questions, otherwise I'll see them. Oh, don't forget your stuff, please, dear God. I always hate carrying around people's IDs and such. Don't forget your wallets and your phones.
Like, what did you do to get to this point? How did you put that in the calculator? I was watching, I was like,
Oh, one thing I do is, okay. So you hit L2, go up to L2. Hit up, yeah. Now tell it you want that to be list 1, which is above the 1. So second 1, you want it to be list 1. Everything in list 1 minus 6.5. You want it to be everything in list 1 minus 6.5. Thank you. Thank you.
I had
Thank you. Sorry?
I missed the quiz on, I believe, last Thursday.
Yeah?
Would I be able to make it up?
No makeup quizzes. Whatever grade you make on the next test will count in place of the missing quiz grade.
Thank you very much.
Sure.
But one more question.
Yeah.
Did you collect the homework from chapter 1?
I collected whatever homework people have done.